Hello, can you hear me well? So my name is Dulma. I work at Facebook. I'm a software engineer there. So actually at Facebook London, we have an engineering office in London. And so I'm going to speak about a tool that we developed there. It's called Infer, and it's a static analysis tool. It's for finding bugs or issues in code before the code gets executed. You need to execute it. So this is a tool that is not specifically for iOS. It's also good for Android and also for C++. But because we have so many features in the tool, I wanted to focus this talk on what we can do for iOS. So we don't have Swift support, let me say for now. Is many of you are still using Objective-C? Good, so it will be for you. But maybe in the future we'll have Swift support. So we all know bugs in mobile apps are particularly problematic because they can crash the whole app or make the app slow. And the update process is more painful than in the web. So you can try to put a new release, but the users may not update and the crash may stay there. So it's particularly important to try to find bugs and crashes before the app ships. So at Facebook, the code gets shipped very fast. They have a very fast development cycle where the developers commit the code, and then the code gets reviewed by other developers, and then it gets committed. There are some more automatic tests and checks, and then it goes into the app really quickly. So then how does one keep this very fast release cycle without inserting too many bugs in the app? And Facebook's answer is like as much automation as possible. So there is very good tools in the CI for testing and also for static analysis, which is what I'm going to speak about. So in case you haven't heard before, this is what static analysis is. So the input is the source code of a program, and then the static analyzer analyzes the code and finds potential bugs. So this particular static analyzer works with pre and post conditions. So, so a precondition is something that should hold at the beginning of a program, and then the post condition is given that the precondition holds what will hold at the end of the program. So in this particular small example is a class, my class, with the method equals. And so it copies the argument and then checks the equality of some field model. And so the precondition is that the order is not null. And then if that holds, it will return that self.model is equal to order.model. So there are many static analyzers out there that can check if programs are correct, if they are annotated with these kind of pre and post conditions. But obviously, nobody wants to write those things. So that's the main reason why these type of analyzers are not very widely used. So also they are generally slow. They run on whole programs. So because we are talking about not just properties of a specific part of the program, but more global properties. So it could be a crash that goes across files and across methods. And so they can take a long time, and it will just produce a list of bugs after many hours. So we have found that this is not particularly good way of deploying such a tool, and people don't like to use it so much. So with Infer, so it has a technology that allows it to find these pre and post conditions automatically. So it doesn't need any annotations. And so it's compositional, which makes it fast. So you don't need to know the whole program to be able to find some bugs. You can analyze parts of the program. And so we're developing it for Android and for iOS, and also for C++. And so this talk is mostly focused on iOS, but there is very good support for Android as well. You can find more on the website. So this is a visualization of how the analyzer works. analyzes some methods, and it finds they are correct. It finds bugs in other methods, and then it combines results of the methods that can analyze to analyze the bigger parts of the program. But then it doesn't need to either analyze everything at once or stop the analysis if there's some problem in between. So that makes it possible to scale to millions of lines of code that we have at Facebook. So, so how fast is it? It depends on how much it needs to be recompiled. So full analysis of millions of lines of code will take a long time, like hours. But normally what we do at Facebook is we send some code change for review, and then we only need to analyze that on top of the analysis of the previous version, and then that doesn't take so long. It can be seconds, it can be like a few minutes. So maybe you have heard of other tools similar to this that are called linters. And so I was going to explain what is the difference. So this tool finds interprocedural bugs that can span over multiple files. And linters are more syntactic checks that are more local to one procedure. And so I'm going to explain later that we also have a framework for linters as well as part of this tool Infer. So for the core tool, we have various types of bugs that we can find, like null dereferences, parameters null check for null, memory leaks, and retain cycles. And so as I explained before, the languages that we support are C, Objective-C, Objective-C++, and a bit of C++, and well, also Java, but not Swift yet. So this is how the process works at Facebook when you submit some code. So there's a CI, then Infer analyzes it, the reviewers analyze it, the reviewers say it's good or it's bad. If Infer finds some bug, it sends it as well. So Fabricator is actually an open source tool for code review that we use. Then this is what Infer would give us as an answer. If they find some bug, it would write a comment saying there is this potential bug. So I will speak about this potential bug a bit later. And then the developer fixes the bug, fixes all the comments of the reviewers, and then the code gets committed, gets through more performance tests and correctness tests, and then gets shipped. So at the moment, Infer runs on thousands of code changes in Facebook's mobile code bases, and it finds hundreds of potential bugs. And so we have a fixed rate of about 60%, which is rather good for this kind of tool. We'd like to make the tool report not so many false positives, so that it has high value, because if it's too many things that are not useful, then developers won't like it so much. So I'm going to show you some examples of the kind of bugs that it finds. So this is the method I showed earlier. So it's a method equals that has an argument order. It first copies the argument and then checks for equality of the field model with order copied model. And what it tells you there is not a real bug, but it is something that you need to maybe check if the method is being called with an argument that is null or not. Because if it's called with an argument that is null, then order copy equals order copy is going to be returning null as well, and then you're going to the reference null, and then there will be a crash. And so this is something that we find useful to report, and so developers then can think like, no, this function won't ever be called with null or yes, and add a check accordingly. So there are other cases where we find an actual node reference where you have the whole place, you know that here is null and it's called with null and it will crash. And this is a case that is actually only a warning. So another example that we have is the memory leak. So the kind of memory leaks that we support are the ones that come from these C libraries, Core Foundation or Core Graphics. So these kind of objects need to be released manually, even with Arc. So in this case, this font object was created with cd font create with name, and then it was used, but then that needs to be released. So this is then the error. The memory allocated to font by call to cd font create with name is not reachable anymore, and then it hasn't been released. So you need to add the release. And another thing that we find is retain cycles. So in this example, there is a class person that has a property handler and a property name, and then a method main where we create a new person, and then we set p.handler to be a block, and inside the block we set p.name to be a name. So in this case, the block will retain p because it's a captured variable, and then p will also retain the block because it sets it to p.handler. So this will cause a retain cycle. A very simple one, but just for clarification. And so Infer will also find this. We tell you that there is a retain cycle involved in these objects. And so as I said earlier, this is more the core Infer, and then for Objective-C, we've also built a Linter framework, which the difference is just less deep analysis. It's more looking at the syntax and trying to find simpler bugs. So it checks for syntactic properties, is faster because it doesn't need to analyze more than one file at once. And also we've made it so that other people that are not in our team can add new checks easier. So the tool is open source, as I will explain in a moment. So we are working towards actually even a domain-specific language to write these rules, so that other people can write the rules and it's more scalable because we don't have the resources to write all the rules. So at the moment we have a few of these checks available. So for example, when a property is defined atomic, but then is accessed directly, not via a getter or setter, that could be a problem. Another warning when you have a property that is a delegate that is strong, that could lead to retain cycles, so it's another warning. Or where we have a property that is a type pointer and is assigned instead of strong or weak, that could also lead to errors, so it's a warning. Or when you have register and observer using NX notification center, and then this observer is already going out of scope and wasn't removed. So we also warn you for that. So these are specific checks that people at Facebook have found useful, and we have implemented them. And yeah, the idea is that the framework can be extendable to checks that people can find useful. So the tool is open source, and this is how the website looks like. So we have various users already. We have almost 6,000 GitHub stars at the moment, and a few external contributors. So to have an idea, the last release, there was about 700 downloads. So it was in September. We will make a release again soon. So it is also used in various companies outside of Facebook. So at Facebook, we use it on the main apps, but also on WhatsApp and Oculus and Instagram. And other companies that use it are Spotify, Uber, Sky, Key1, Moneylow, and Marks and Spencer. And so to install it is in Brew, so you can do Brew install Infer. And otherwise, there's also possibility to install via Docker. So you also can download the releases from the GitHub page and then just compile it. So we have various build systems in the context of iOS: xcodebuild, make, bug. And then the command is infer -- and the build command. For example, xcodebuild, target, and everything you write otherwise, or bug build. And so I have to say, if someone has used it already with xcodebuild, we have had some issues on GitHub that there are some problems, that there are some compilation errors, and so we are working on a new integration with xcodebuild that should be available in like a week. So basically what we will do is use xcpretty to get a JSON with a compilation database, and then use tag compilation database, and that is a bit more sturdy, so it should crash less. So yeah, in the command line, as I said, is infer -- the build system, and you can also specify which analyzer you like. So by default, we have both analyzers, infer and the linters, and then you can specify -a infer or -a linters. And why would you like to do that? Because the linters are faster. So if you want something faster that gives you some warnings, this is what you can do. So in the website, there is also a link to this Codeboard page that is a web IDE. So you can play around with it in this web IDE as well. And so just to give you a bit more concrete examples of times and bugs found, because I cannot use Facebook code, I thought I would show you a case study of a real iOS app that is open source, which is of this xkcd comics you probably have seen. So the app had 135 files, about 36,000 lines of code. And so the time it took to analyze it with Infer was 6 minutes, and with only the linters it was 3 minutes. That was on a laptop. And it found 18 issues with Infer and 31 issues with the linters. So I hope you can read that. So that's one of the issues found, parameter not checked. So in this case, it was a block that it was passed as a parameter to a function handler, which is quite a common thing to do. And when you try to execute the block, that is nil, it crashes. So it just tells you, you probably want to check if the block is nil before you use it. Another example is this strong delegate warning. So there's a variable, a property delegate, where it didn't specify anything, and if you don't specify anything, default is strong. Might be a problem. And another one was this Regista observer being deallocated. So it was a class comic list view controller, and so there was in view.load, they added the class as an observer to an S notification center, and there was no method to remove it. So Infer finds that out and tells you that it's probably an error. So that's that. In the future, we are working on adding more bug types, both in the interprocedural analyzer and in the linters. And we are also working on a domain-specific language to write the linters. So the idea would be that you just write a rule in some text file using specific language, and then Infer can use that rule. So it will make it much more scalable. And so we have also been working on performance improvements, especially at Facebook. The code gets bigger and bigger, and we need to scale with it. And we need to be able to report in the CI rather fast. So it's a big focus of us to work on performance. And as I said, we are also working on this beta integration with xcodebuild to make this experience less painful. And I was hoping to get the release finished by this talk, but it will be maybe next week. So have a look. And so Infer can be found in GitHub. You can download or you can report the issues. And the website is called fbinfer.com, so you can find documentation and issues there. So in general, it's interesting to us to know if you use the tool, if you don't use it, what are the blockers, the problems? So they let me know or write it in the issues, and yeah, we're happy to improve it. Thank you. So we have quite a bit of time for questions. So if you have questions.
Yeah, we have really good time for the questions. So, okay, I'll ask first. So which